Hello, everyone. It is my great honor and pleasure today to host Suparna Bhattacharya, Distinguished Technologist at Hewlett Packard Labs. Hello, Suparna.
Hello, hi Dejan. It's wonderful to talk to you again. Yeah.
I usually start these podcasts with asking people how did they become whatever title they have. So you are a distinguished technologist, but you didn't just become distinguished technologist overnight. You had some career that brought you here, and I'm
Yeah.
sure young engineers would like to learn how did you achieve that.
Okay. Yeah, I've had a 27-year long career so far, so it is a long journey. I did my uh, BTech in engineering in IIT Kharagpur in '93, and so I've been working since then. I spent 21 years at IBM and been HP for 6 years now. And as you said, and when I started my career, I actually wanted to take up an academic career, and I instead landed up in the industry because I decided to stay back in India instead of flying abroad. And at that time, I really had no idea what a career in computing meant. I actually didn't even take courses in operating systems or computing related courses. I was more interested in things like pattern matching, fuzzy logic, and so forth. And maybe that connects, me back to the AI role that I play in the AI research lab today. So I'm back full circle. But then when I joined the organization, that's when I realized I discovered that I really loved working on operating systems. And that was kind of my first project. So I loved technology. I loved building system software. And I would say kind of break up my career into a few segments. Like this, the first set of segment is where you're working on the problems that people have defined for you. You most of the time you're very curious, trying to learn and trying to figure out how to solve the problems that have been set for you. I think the transition for me happened a little after that is when I started working. The early career, I worked on the microkernel operating system. So that was the first operating system I worked on. And then I got a chance to work on a project which was really a collaboration with IBM Almaden Research Center. And so it was my first experience of taking something which was a concept in research to product and seeing that realized into it was actually became a part of the DB2 product. And so that was a very interesting journey, both working with researchers and being through the entire journey of a product life cycle and then supporting that product and the issues that were there. So that was the end of the next level of growth. And that was kind of the time when I was, maybe we can talk about this more, but at that time, back in India, it was kind of typical at that time. It was very difficult to have a purely technical career path as we know today. And that's kind of,
Mhm.
you asked me about being a distinguished technologist, which is really being on a full technical career path all along. And so I was growing in the regular trajectory, becoming doing more project management, and I was getting nominated for executive development and so forth. But then I sat back and I realized that I really love technology and I wanted to stay a technologist. I was also reaching a phase in the project where I knew there was a very difficult architectural challenge and I knew I could take that up. Right? And so that's the time when I decided that I wanted to go for a technical career path. And I had that discussion with my manager. And I would say that I was really fortunate. I think all along in my career, I've been fortunate that I got that support saying, okay, we don't know how this is going to work out, and you have to figure out your path, but it
Mhm.
is possible. And so that's my start of the journey for being on a technical career path. And that's when I actually, 7 years after working, is when I actually did my first patent. I wish I had I knew how to do that before, but I learned how to do my first patent. I had my first publication. And the big jump for me came when I started working on the Linux open source with the Linux open source community. IBM had started this Linux Technology Center, and I was really keen to work on that. And so that gave me a very wide exposure to the external community. And along with that, I was also getting a wider exposure within IBM. And because there were others who were also trying to have a technical career path, and it was really that having that group of people for us to all develop these things together and may start making proposals, start making strategic proposals and so forth. So I ended up working with something called an IBM, we call it a technical experts council. And it was it was an a kind of a chapter of the IBM Academy of Technology. And so all of these exposures kind of gave me, slowly kept giving me that breadth. All of a sudden, I had found that my career growth earlier, because of taking a technical career path, has been slower, but all of a sudden it started accelerating, and I was lucky enough to get that first corporate promotion in the technical career path in IBM India. And so that was the big jump. Now, after that, and maybe we'll talk about that a little more, was that's the next phase, right? Where I was saying, okay, I worked on the Linux kernel, and those days the Linux was, we were trying to get Linux ready for the enterprise. In some sense, Linux was catching up with other operating systems. And we had reached a time when it felt like Linux had caught up, and we had to figure out, what do we do next? And so that was the time when you start thinking, okay, that next phase, when you start saying, can I start defining the problems that we work on, and how do I learn to do that? And that was kind of the time when I decided that maybe that I wanted to really explore research. I had always thought of doing a PhD before, and I decided to explore research. I did a part-time PhD, and then I moved to a career in research in IBM Research. And so that was kind of the next jump. And that's kind of after a few years in research is when I actually joined HPE. I had that opportunity. I was very interested in persistent memory technologies, and and particularly HPE was working on the machine at that time. It was very exciting. So when I got that offer from HPE, I came on board. And that's kind of how, the combination of my past experience and my research experience, I guess, was brought me to being a DT.
So you mentioned you were working on a microkernel. Which microkernel was that? Was that IBM microkernel, which
Yes,
was
yes. Which was
derivative
based on the
from
CMU Mark,
Mark?
yeah, operating system.
Yeah,
Yeah,
yeah, I was working on that for my PhD, and then at Open Software Foundation as well. So
I
we're
see.
working on the same thing on different side of the fence.
Yeah.
And you said you did your PhD thesis later in your career. You did it while you were working in IBM, or how did it happen?
Yes, it was a part time. So it was an so Indian Institute of Science had an external registration program. So I did my PhD part time through that. So I had a guide from IBM, and I had a guide from the university. Professor Gopinath was my professor advisor there. And you know, so I think it was a very different experience. So as I was saying, I picked my research subject as I was very interested in energy efficiency, and I wanted to do something more than what we could do at the systems level, which is, often most of the time we save energy by turning things off or slowing them down. So you can turn off memory banks, turn off processors, or you slow them down. And I
Mhm.
realized that there was not a lot that we could do purely at the operating system layer. As much as I loved working on the kernel, I realized that a lot of the inefficiencies were further up, higher in the stack. And so I came across this problem of framework-based applications, and a lot of papers and work on how much overheads are there in those applications. And I figured, if there is so much overhead, then how much energy could we save if we solve that problem? And it was a really hard problem to solve. And so my PhD thesis, I think that the cool thing there was, it was a very good piece of advice that my thesis advisor gave me. He said, you've done systems now, pick up the other subjects. I take courses in other subjects. So I took courses in program analysis, I took courses in machine learning, in power performance modeling. And my thesis work, I ended up using all of that. So I ended up working with each of these communities. It was a very uh, different learning experience for me, because when we were doing product development, you kind of come top down, because you architect the product, you design it, and then you build the pieces. In research, I realized the outcome was really the insight. So it took me a lot of, I had to really learn, how do you really go and produce insight, and how do you really
Mhm.
follow your curiosity, discover things, and
Mhm.
then synthesize your insights from that. So that was a pretty interesting learning experience for me. Both, I think, the research experience, as well as working with all different communities, with the program analysis community, the systems community, with the machine learning community, and learning from that. So
And then you also wrote a book And tell us a little bit about your experience writing the
Oh,
book.
so I wrote a book actually while I was at HPE. So this was actually a follow-on from my thesis work. And as I mentioned, my thesis work, I realized that this problem of software bloat could impact energy efficiency, power, and performance. And when I came to HPE and I started working on persistent memory from a storage side, I started realizing that this problem, it was deja vu all over again for me, that I realized that this was a problem that really makes it hard for us to take advantage of emerging new hardware technologies, because the hardware latencies are going down and the software path lengths were going up. And so that's kind of what inspired me, motivated me to keep developing those ideas and write a book. And this book was actually written in collaboration with my advisor, Professor Gopinath, and my colleague, Doug Voigt, who I worked very closely with. And we tackle this problem of of software bloat. We tackle the problem of how do you really make software stacks evolve as new technologies emerge. And also because I had started working on AI and analytics kind of applications, and what could we do from a storage side to improve them. So I also discovered this notion of, the idea of the book was that we should, can we make the resource consumption of software proportional to what it is trying to do? And so proportional to what the functionality is, in proportion with what the hardware technologies allow you to do and be as fast as that. And thirdly, consume data in proportion to what you need for analytics applications. Yeah.
Very nice. So you transitioned then to AI, which was really coming back because in your early career, you're also interested in it.
Yeah.
Tell us a little bit more. What are you working on? What are these interesting problems now that you're attacking?
Yeah, so it started with when I was saying that I've looked at AI applications, and because I was a system software developer, you tend to always look at it from the place that you are used to. And I realized that the goal of AI applications was to derive meaning or insights out of data. And all the cool things that we had done in system software, virtual memory, how we design storage tiering, and all of these things, they are not really geared at that objective, because they are geared at optimizing what the applications seem to be doing, but they do not know that you're really trying to derive insight out of data. And so I was very curious to see that at an infrastructure level, what could we do to make AI applications better? And my current work kind of relates to that. So if I look at AI applications today, at the maybe at the storage or infrastructure level, we provide them data access, we provide them efficient data access, reliable data access. But what they really need, the applications need, is good data at the right time, data that's very rich in insight, so that you can actually get better models out of it. How do we build systems to do that? How do we build systems that will prioritize that insight rich, clean, trustworthy data and get it to these AI applications? So the idea here was that we can do that if we can learn what the AI applications are actually trying to do. And we
Mhm.
can learn that by observing what these applications are doing with the data. And so that's kind of what led me to this. The project that I'm working at now in AI Research Lab is what we call a self-learning data foundation for AI. And the self-learning happens by tracking these AI applications data lineage, right? That how are these applications, as they are going through these data transformations, what are those transformations, what intermediate outputs are they resulting in, what's the metric, what's the accuracy metric, and other kinds of measurements that are resulting from it. And we observe all the AI applications that are working on a piece of data over a period of time. And so maybe if there are many data scientists who are working on it, we learn from that collective information, and then build a lot of these self-learning techniques. So that's the key idea.
So if I understood you correctly, you are trying to identify that lineage, how data and models were generated, and then using this, then that leads to self-explainable AI. Is that right?
Yes, so this is one of the things. So you all want to have AI that's trustworthy, where you don't even just want to know the right answer, but you want to know that it got it right for the right reasons. And so then you have confidence on that. And by tracking, as you rightly pointed out, by tracking this information all the way through, you can now trace back. And it takes a lot more techniques on top of that information, that you can process that information and then come up with the reasoning, and get like lead to more explainable AI.
And I presume that in order for this to be broadly trusted and adopted, you need some sort of standard. So presumably you are going to take this data foundation, as you call it, self-learning data foundation for AI, and have the world, researchers, scientists, developers, adopt it so that any user and any other developer can then interact with it and obtain explanation and things like that. Is that the plan?
Yeah, so the way we're thinking about it is we would like this to work with open source communities. So, I mean, data lineage is not a new thing, or even tracking AI models and AI experiments. There are lots and lots of tools there. But as you see, the problems are there. Some are proprietary tools, there are lots of separate open source projects. So it's a very fragmented ecosystem. So what we would like to do is to have kind of the equivalent of Git. So when I was working on the Linux kernel, I think Linux kernel development took a huge leap after Git came into existence. So we would like to see the same leap here. Could we have the equivalent of a Git for AI data and AI metadata? And the way we would like to do it is, there are open source projects. There's an open source project, for example, called Data Version Control. There are other open source projects like MLflow. So there are a lot of these open source projects. There is the Kubernetes ecosystem has Kubeflow. So we would like to really work with these open source communities, connect these things together, and yes, and make that available to everybody, so that that lineage information gets tracked and is usable by everybody.
You made really important contributions in the past to open source community, especially Linux. You are authority in this space. So can you tell us about the importance of open source to the general industry?
Yeah, I think, I mean, my experience with open source, I think there are many aspects that really make it very exciting and interesting. So I think, firstly, as I said, if you're doing something with open source, then it gets very wide adoption if it is successful. And the cool thing about working with an open source community is, because it has this wide adoption, you get a lot of feedback. So every time I was working, for example, on the Linux kernel, when I would post a patch or propose something, I would always get feedback from very diverse kinds of users saying, okay, this didn't work for me, this broke for me. And that forces you to go back and think and develop things which would really work very broadly. And so that feedback loop, that adoption loop, and I think that's the real power of working in the open source community. Yeah, and so I see that that's true also in the AI area, for example. But I think the advantage we had in Linux was, uh, a lot of people were working on the same community, and so it was much easier in that sense, that it was easier from an adoption for people who were adopting it. It was obviously more difficult for us who were trying to build that. Yeah.
But you were also engaged with professional
Mhm.
organizations, either um, worldwide or national. So worldwide IEEE, and then national, Indian Institute of Science, Indian National Academy of Engineers. Can you tell us a little bit from your experience about the importance of these professional organizations?
Oh yes. So as you said, so member of ACM, member of IEEE, and recently got elected to the Indian National Academy of Engineers. So one thing that I have realized in my career is, as I was saying, just like the open source community, that was very interesting, and to get that feedback from the open source community. Likewise, when we work in the professional, like especially when we work with conferences, and which is what I started during my PhD research, and you start going to conferences and you start working with the program committees of the conferences, you get a very rich perspective from that point of view. And then these these organizations that you're saying, we're talking about like IEEE or INAE, these give even broader perspective because we have people who are from the industry, people who are from the academia, people who are from many different disciplines beyond us. So I think that engagement, at least to me, is it really opens up your mind, and it also, I think it's also an opportunity. I feel personally that I had a lot of help in my career. I had a lot of support which helped me grow, and so these are also opportunities for us to reach out to others in the community and try to help in whatever way we can. For example, I love doing workshops for grad students because for me, the PhD was a big learning experience, right?
Mhm.
It was nothing like what I expected. And I know that every PhD student faces that. Or if I look at the domain of system software, I think a lot of people do not necessarily realize, how much a career in system software can offer, and being able to see that full trajectory helps them. So I love doing these kinds of sessions, and these kind of communities and engagements and academy engagements all kind of give me that opportunity to do that.
And these professional organizations are also basis for recognition. You recently got a few awards. Beside, as you mentioned, being elected on Indian National Academy of Engineers, you got an award from India Council, from Indian Institute of Science. Can you tell us a little bit about these? And by the way, congratulations.
Okay, thank you. uh, yeah, so I think the awards are, in some sense, they are accumulation of what has happened past in the historical sense, right? So it's not like you do anything specific for an award. But I think it was very nice to be recognized by the IEEE India Council as their Women Technologies of the Year award. And it, somehow maybe this year has been the year of awards. A couple of years ago, I got this enough. Next Generation Women's Leader Award, which was more from an industry point of view, and then IEEE kind of gives the recognition from this professional organization. And then recently, I got an award from my alma mater, Indian Institute of Science, where I did my PhD, the Professor S.K. Chatterjee Award. So it's very satisfying to be able to get this, but I also feel like there's a lot more to do, and
Yeah.
it's
But while satisfying to individually and as a recognition, I find it very important to become role model for your young students so that and that's one of the reasons why we are doing this,
yeah,
so that young Indian women can learn how to become as successful as you have become.
yeah,
And this brings us to this broader notion that at HP we call a force for good.
yeah.
And you already gave us some examples how you're helping grad students. Can you tell us about other examples or giving back to community, humanity?
Uh, Yeah, so I think in HP, even last year we had the whole effort around COVID, AI research, right? So there was this whole effort to say, how could AI or how could AI researchers help with the COVID initiative? And we had a lot of volunteers from within HPE to help with that. So that was really one big example. And I mean, I was also part of that initiative. There is, I also feel that in terms of, we going through, we're since I'm working on data, right? So one of the things that you realized in the COVID initiative and many other initiatives that we have, for example, I'm working with Janice Sankas and Lynn Nees on something we call a data sets as a service standard, because what we realized is that in many areas, for example, agriculture, where people really you can make a huge impact with AI if you can actually give farmers much better insights about what crops to grow, what are the things that they could do, what would give them better price and so forth. But that requires data. And we really don't have a good system in place for these kinds of data to be available. A similar kind of situation for health in some of these areas. So I think that's one of the other areas that I think we are trying to play a role in and see if we can really provide these kinds of open data sets as a service and solve the challenges of making data accessible for these big social societal problems, so to say.
A great example. Another topic that has really broad implications is about inclusion and diversity. It is really critical topic in United States, but also in India and around the world. So, can you tell us your perspective, both from what you have seen in India and what you have seen around the world?
Yeah, so I think the I mean, there are many elements to inclusion and diversity. So there might be gender, there might be geography, there might be race. So there are many of these elements. I think one of the things for me was this whole experience, I think, of working on the Linux kernel, and some of that is really the importance of valuing diversity. And really, I've seen this, personally, that when you have diverse thoughts and diverse people, diverse cultures in a place, you just have a lot of richer insights and explosion. And obviously, that is only possible if not just if you just don't have these diverse voices in the room, but they feel safe enough to speak, right? They are. And I often used to get asked when I used to work on this, there were many times when I was the only woman in the room, or the only person from India on the phone. And I used to always say that, no matter where you are at, whether it's a physical room or a virtual room, what it matters is what you are there in the room, to discuss, and not who, not who you are individually. So I think I've seen over the years there has been a lot of efforts to improve these. And one thing I think, so there is diversity, there is inclusion, but I think there's the third aspect of enablement of because if you enable people to succeed, I think when we succeed in a career, if I look back, it's not my own success. It's really because people reached out and supported me and helped me at just the right junctures. It's almost like, and it gets harder when you're trying in your technical career path. I think when you're reaching that stage, when you're trying to do innovation, you're just trying to do things that are uncertain, that even you are not sure of. That's kind of the time where we really need support. And I think if we are able to bring those kinds of mechanisms in, maybe the right mentoring, the right support, the right resources at the right time, then I think we will start to see more people in senior leadership roles coming from diverse backgrounds. And we are seeing that today actually in in HP. I mean I feel very happy that over maybe the last 3 years or so, we've seen multiple people, very strong, women technical career path candidates who have now made that journey, right? And they are progressing in their technical career path. So I think that's the crux crux of it.
Day in, day out, you're focused on technology. Do you ever have time to unwind, and how do you do that?
Yes, I love reading books. I love going for walks. I love spending time with my family, whatever time I can get. So little things, but they really keep me energized. Yeah.
What book did you read last?
Yeah. So interestingly enough, I mean, I do read all kinds of books. I read technology books. I read, my husband is in the Indian Institute of Management, so I read business books, but I also read, I love physics and I like to read books around that. But the book that I'm reading now is actually a book on AI, but it is a book about AI weirdness. It's a book by Janil Shin, and she has very interesting examples of, using deep learning to create poetry and create recipes. You mentioned you loved cooking, and using that, she's really bringing out these very interesting examples of where AI works well and where it doesn't, where it fails in very weird ways. So it's a very exciting, very fun book that I'm reading right now.
When you and I chatted in preparation for this podcast, and I asked you whether you do any sports, you said you didn't, but that you support your husband running marathon. And I was just wondering, can you use any of data lineage techniques and data foundation to track his results and then enable him to be more effective in marathon?
Yeah, he is already very effective. He's been running marathons. Yeah, he started with a running group about 10, 12 years ago. And I've seen that progress over years. So it's it's um, actually it's very inspiring to see that group and how they support each other, and how they manage to actually make that kind of progress. And earlier it used to be, like you said, supporting him for marathons. So he would run an ultra marathon, or he would go for maybe the Bangalore Marathon, and I would be there. These days, he just runs marathons in the campus. He just goes out for a run and comes back and says, I ran 5 hours today. So it's just become regular for him, right? So, yeah. Yeah.
Thank you very much, Suparna. Some great examples for young generations. I'll make sure to show my daughters this video. I learned myself, and I'm sure they will, and many other young women. Thanks for joining
Yeah.
us.
Thanks.